Hello. So I just want to wish everyone a happy Pi Day because today is March 14th, which is 3/14. Pi Day refers to March 14th because the decimal for pi is 3.14159. But what makes it special is the fact that these numbers in the decimal go on forever, and they also don't repeat a specific pattern. Because of those two conditions, this makes pi an irrational number. And irrational numbers are defined as numbers that can't be written as a fraction. And they can't be written as a fraction due to the decimal never ending and never repeating a pattern. So with that being said, why is pi important? Well, probably the most relevant application of pi that people would know is circles. So in geometry, you probably learned about circumference and diameter and radius of a circle. Pi is special because it's equivalent to the ratio between the circle's circumference and its diameter. So pi is a constant as well. So it never changes. It's always this number. So from this circumference equation, you also probably have seen that the area of a circle is equivalent to pi times the radius squared. The cool thing about all of this is that pi is a constant, so it never changes. And if you can understand pi as being the ratio of the circle's circumference to its diameter, then that will take you pretty far. Because now, if you understand that, you can rearrange the circumference equation, obviously. If you were to take this diameter, and then if you were to unravel the circle and lay those two lines out next to each other, the circumference line would be about 3.14159 times the length of the diameter. Now that you know that it's the ratio between the circumference and the diameter of a circle, you can start to use it in other equations and almost derive the other equations based on just the equation of the circle, the circumference and the area. So, for example, if you have a cylinder, right? If you can visualize a cylinder as just starting with the surface area equation, right? That would be the area of the entire surface of the cylinder. So what would help with this, how you can derive this equation, is when you think of a cylinder, think of it as two circles. So I'll draw a circle plus a circle plus this middle section is just a rectangle. Because if you were to unravel this middle section, like if you were to unwrap it, it would lay out as a rectangle, and then you have your two circles here in their areas. So if you were to break it down and say that the surface area is equivalent to this, right? Now, to get the formula, all you have to do is think about the elements that make it up. And the surface area would be the area of this circle, this circle, the area of this circle, plus the area of this rectangle. You can think of it now as surface area would be equal to, right? We already determined that the area of the circle is pi times the radius squared. So you have pi times the radius squared here and pi times the radius squared here. So because you know the formula for area is this and you have two circles, That means you can write this expression. This is equivalent here as 2 times pi r squared. And then you got your plus, and then, right? The area of a rectangle we know is just the length times the width. So that would be equivalent to the height times the circumference. You would get the circumference, right? Pi times diameter times h. You can easily find the diameter if you're given the radius, because the diameter is equivalent to the radius times 2. So then this term, I'll just rewrite it here. I'll rewrite it as a, so an equivalent statement would be 2 pi r squared plus 2 times pi times the radius times the height. For volume, we would have volume. Volume is the 3D space of the cylinder. And how you can kind of visualize that is if, say, think of this cylinder and think about, like, if you were to draw like stacks of circles, right? It would just be the area of these circles times the height. So that means the volume of the circle would be the area of the circle, pi times r squared times the height. In conclusion, pi is very useful when thinking about circles, because it refers to, once again, the ratio between the circumference and the diameter of a circle. And knowing that relationship and understanding it that way can help you think about equations of other shapes and figures that have circles in them. So yeah, that's how pi is relevant to geometry specifically. And there's a lot of other applications of pi and uses. So look out for another video on that for sure, because pi is definitely not limited to just this context, but in this case, it's very useful. So I wish you guys a happy Pi Day, and hopefully you ate a lot of pie today. See you guys next time.